now we're going to continue our review for the Unit 4 lecture exam in astronomy by talking about Lesson 21 on fundamental forces and fundamental particles. So make sure and read the lesson objectives for this. And then you'll notice that in your textbook that there is no particular chapter that goes with this material, but you can find all of everything I'm talking about by using the index of your textbook. All right, first, you do not need to know anything on this page other than the fact of what an atom is. So an atom is going to have a nucleus and then surrounded by electrons. And then the nucleus is going to be composed of protons and neutrons. So you definitely need to know that. Okay, next you need to know what a particle accelerator is. So it's called an atom smasher. It's also called a particle accelerator. And you need to know how it works. So the idea is that we use electricity, electrical voltages, to accelerate an electrical charge. Then we're going to use magnetism to make the trajectory go around in a circle. And then we're going to collide particles together and then look at the other particles that come flying out of the explosion. And so from using these experiments, we have found many different kinds of fundamental particles that reside inside of protons and neutrons. Okay, from this, all you got to know is that inside protons and neutrons, there's lots and lots of particles. Now, you may recognize the word lepton from this chart, and then we'll talk more about that later. But leptons are a fundamental particle. There is nothing inside of leptons that we know of. Now there is stuff inside protons and neutrons, but not inside of leptons. So leptons are a fundamental particle. Okay, gotta know what quarks are. So matter is going to be composed of 6 kinds of quarks. And you don't need to know the names of the quarks, and it's going to be composed of 6 kinds of leptons, and you don't need to know the names of the leptons except for 2. So you should recognize the electron, and you should recognize the neutrino. So for every type of lepton, so there's 3 kinds of these particles, there's a neutrino that goes with it. And so this would be the neutrino that goes with the electron. So I do want you to know what a neutrino is. It's a fundamental particle that is necessary whenever a proton changes into a neutron. It will also emit a neutrino. So that's where they come from. Another way of thinking about it is when a quark, like an up quark, changes into a down quark, that is also going to emit a neutrino. So that's where they come from. I would also like for you to know that inside of protons and neutrons, there are at least 3 quarks. Now there could be more than 3 quarks inside of them, but there's always going to be at least 3 inside of a proton and 3 located inside of a neutron. So that matter is ultimately composed of quarks and leptons. Okay, got to know what antimatter is. So antimatter is going to have, it's going to look like regular matter, except it has opposite electrical charge and opposite electrical spin. And so for every particle, such as the electron, you have an antiparticle that goes with it. So this is an ordinary electron that has a negative charge. But an electron that has a bar over the top of it means it's antimatter, and it would have positive electrical charge. And then if those two things were to come together, it would turn into pure energy according to that formula, E equals mc squared. And so for all of the quarks and for all of the leptons, they have antiparticles that go with them. Okay, next you've got to know about virtual space. So let's take a break, and when we come back, we will talk about this.